Hello guys, welcome back to my class. So in this lesson, we'll be learning the basic components. What is identifier, data type, variable declaration, and everything you need to know before start to write your own program. Okay, before we start, please make sure you have watched my first video and give it a like if you like it. Okay, so this is the basic structure of a C++ program, which including the first part here is the directive, and the second part here is the main function body. So in this example, the main function body consists of two different types of statement. We have a declaration statement used to declare variables, and executable statement, which is the part where the command is executed, processed, and generate some result to the user. Okay, so let's understand some components in the C++ program first, which are the header files, library, and the predefined function. Okay, so assuming that you are writing a program and you would like to ask the user to key in some input and to display some output. Also, you would like to calculate the power of 2 of the value that user key in. So in order to complete the task, we have to use some predefined functions in the C++ environment, such as cin, cout. Cout is to display the statement on the console, cin to ask the user to key in some input, and we have one predefined function, power, to calculate the power of 2 for the value that user key in. Okay, so each of these predefined functions is basically located at their own library respectively. For instance, cin and cout is located inside this IO stream library, and this IO stream is known as header file name. And this power is a predefined function which stay inside this library and known as cmat. This is the header file name. Okay, so this is the file name for a library cmat, and this is the IO stream, is a header file name for this particular library. Okay, so in fact, this predefined function is a built-in function that pre-compiled in the C++ environment, and every predefined function is formed by its own source code. For instance, power, there is a series of code. Okay, but as a programmer, we don't really need to worry about what is happening inside this source code. We don't really need to understand what is happening inside these predefined functions, as long as you need as long as you know when to use it and how to use it. Okay. Just like if you are hungry, then you have to go to the right place, which is restaurant, to order your food and fill up your stomach. If you want to buy some spanner screwdriver, then you have to go to the hardware shop and buy it. We don't really need to know what is the making process of this food and how the spanner is being processed. No. Okay, so same in the programming. We don't really need to know the source code of each of the predefined function. You just need to know how to use it and when to use it. Also, if you like to use all these predefined functions, you have to notify the compiler, okay, to pre-process all these predefined functions first before the actual compilation happens. So how to notify? By using this # include. Okay, tell the compiler, please help me to include this source code into my program first before the actual compilation takes place. Okay, so there are some rules when using the directive. First one, always put at the top of the program. Second, preceded by this #. And the third one, never put the semicolon at the end of the directive include. Okay, for instance, look at these examples. You have an include IO stream, include cmat. If I put this semicolon at the end of this directive, it will throw me the error. So I will run the program. So it will show me the error warning. Okay, so if I remove this hash sign, also error. Okay, so here are the rules for the directive declarations. Always put at the top of the program, preceded with the hash sign, and never put a semicolon at the end of the include line. Okay, it is invalid. Okay, so there are a numbers of directives that are available in C++ programming. So in the previous lesson, I will show you this directive defined. So here I will show you another directive known as the include. So include directive is used when you would like to use the predefined function in the C++ environment. Okay, so before you start to use the predefined functions, identify first which library that the predefined function is located at. Okay, so you may go to the Google. Okay, you can just key in. Okay, just key C++ library. Okay, go to this website cplus.com. Yeah, here we have a list of this C++ library. Okay, for instance, I create inside this CMAT. CMAT is one of the library, and CMAT is the header file name. So here I have all this predefined function list. Okay, so you can just click inside. For instance, power of 2, power, yes, power. Then it will show you the proper way how to use this particular predefined functions. What are the parameters that you should use, and some useful informations for the particular predefined functions. Okay, so maybe you can try this by yourself. Okay, so here are some syntax. Here the syntax for the directive include. So put a hash sign, include your header file name, for instance iostream cmat. Okay, so the most commonly used predefined function in the C++ is the cin and cout, where cin is to request the input from the user, and the display and the cout is used to display the output on the console. Okay, so to perform both inserting and displaying tasks, we have to include this command directive hash sign include iostream, and then using namespace standard. Okay, so if you omit either one, okay, let's say you omit either one, it will throw you error. Okay, so bear in mind, if you want to use this cin and cout, remember include your directive and also the using namespace standard. Now let's move on to the command. It is pretty important to include the commands in your program. There are two purposes. The first one is to let the reader, okay, the person who read the program, to understand the meaning of the code. So you are the programmer, you write the code, definitely you understand what you are writing, right? But somehow other people that don't know, they don't understand. So they have to understand by reading the command that you put in. Okay, and secondly, we are a human, we are not a machine, and it is impossible to us to remember every single line of the coding. So this command will help you to refresh or trigger your memory when you are about to read back your coding in the future. And we have two types of commands. The first one is the line command, when you have a short command, and when you have a very long command, more than one line, then you have to use this block command. Okay, so here is the example. Here's the example. You have a very short command, you can just put this double slash. If you have a command more than one line, then you have to use this slash star, and then close the command star slash. Okay, so let's look at the example this. Okay, here is the example of the command. Okay, here is the example for the command. If you have a command more than one line, then you have to use this block command. slash star, and then close the comment star slash. If you have a very short command, just use this double slash. Okay, if you use single slash, it will throw you the error. Okay, it will show you the error, syntax error. So for the block command also same. If I miss out one of the symbol, if let's say I remove this close command, error. Okay, syntax error. So now identifiers. So identifier is a programmer defined name for the program element, such as the variable name, the function name, and the namespace name, and so on. So everything in this words has a name. Your parents give you a nice name, a good name. So you as a programmer, you have to provide a good name for every variable that you create. Also, every name for the variables, functions that you create. Okay, so in the programming world, in the C++ environment, there are three rules that you have to follow to declare a variable. The first one is must consist only alphabets, digits, and underscore. Okay, the second one, first alphabet must be alphabet or underscore only. No digit is allowed for the first alphabet. The third one cannot be the same with the keyword or the reserved word. So what is the keyword or the reserved word? So basically this reserved word is the word that has the predefined meaning in the C++ environment. Okay, if you use any word here as your variable name, it will throw you the error. Okay, so I will show you the example. Let's see, we use case. Okay, case as our variable name. See, it will throw you the error. This is the keyword. You cannot use a keyword as a name for the identifier. Okay. So let's do some exercise. So test valid and invalid identifier. So refresh, what are the rules? Consists of only digit, alphabet, underscore. The first alphabet cannot be digit. The third one cannot be the same as the keyword or reserved word. Or the first one, total cells. Yes, valid because it consists only alphabet and it consists only alphabet. And the second one, total underscore cell. Yes, valid because it consists only this alphabet and underscore. Third one, total dot cells, is not valid because you have dot here. Okay, it's not allowed because the rules of the identifier, the first rule must consist of only alphabet, digit, and underscore. Okay, if you have all these illegal symbol dot, then it will throw you the error. Okay, next example, fourth qtr cells is not valid also because it's violate the rules number 2, because the first alphabet must be alphabet or underscore, cannot be digit. Okay, and the last one, total cells, you have this dollar sign, also is an illegal symbol, so invalid. Okay, so remember, always use the meaningful or descriptive names for the identifier. Okay, so look at this example. You would like to declare a variable name known as a future value of an investment. So if you look at the first and the second variable name, f3, it's too short and didn't bring any meaning. I can't understand what is the meaning of f or f3. Look at the example number, third example, future underscore value underscore of, it's too long. It's too long. is not the appropriate. Okay, the last one, yeah, this is the best one. Future underscore value is bring meaning, and it is not too long and not too short. Okay. So let's move on to the data type. So data type is a type that defines a set of the value and a set of operations that can be applied to those values. In other words, a data type is an attribute of a data which tells the compiler how the programmer intends to use the data. Okay, whenever you want to create a new variable, you have to declare its own data type also. For instance, you have 4 variables here, length, width, area, parameter. You have to include their data type. If you omit this data type, it will throw you the error, syntax error. Okay, so we have 5 common data type in the C++. The first one is char. Okay, char is used when you would like to create a variable to store only a char. Okay, to store a single char, you have to put this single quote A. Okay, you have to put single quote. So I'll show you the example here. So I create a variable. I would like to create a variable to store a char. So I have to declare the data type, and then the variable name, maybe gender. Okay, gender. So equal to, if I omit this single quote, I put F. So let's see what happened. Alright, it will throw you the error. Okay, so make sure that if you want to declare a char, you have to put this single quote. Okay, then become valid. So the second type of data type is the integer. So integer is stored a value which is formed from integer. It can be a positive, it can be a negative. Also we have a boolean to store either true or false value. So 1 represent true, 0 represent false. And we have a float and double to store a decimal number. Also it can be a positive or can be a negative. So a double, what is the difference between this float and the double? So the double is more precise, will store more decimal places. Okay, so here is the syntax to define the variable in the C++. So in C++, we cannot directly perform a calculation without notifying the compiler what kind of data type for the particular variable. Okay, for instance, you would like to calculate a value. Okay, A equal to 5, B equal to 6. Then I perform the calculation A plus B. Okay, I run the program. It will throw me the error because the compiler don't know what is A, what is B. So you have to notify what are the data type for this A and B. So I put integer. And yes, free from error. Okay, so remember, whenever you create a variables, you have to include this data type in front of your variable name. Okay, so so let's look how the declaration actually works. So when you are creating these variables, gender, okay, a space, okay, a space named as a gender will be reserved or created in the computer memory. It's ready to be stored, a char. Okay, so now you key in the F. So the F data will be stored inside this space. So same as others, you have an integer year, so a space will be created to store the year from the data type integer. and the price you have another space to store a value which is in the float, and the pi is another space to store a value from the double data type. Okay, so here example, this is how you declare variables, and this is how you assign the value into your variable. Okay, and bear in mind, please assign a value. Okay, this is the value. Please assign a value which is matched with the declared data type. Okay, so at some occasions, you might have already know what is the initial value of some variables. Then you can just assign this value during the variable declarations. We call it as initialization. Okay, for instance, child, gender, this is how you declare variables. So you can straight away assign this value during this variable declaration. If you know this value earlier, you know that pi is equal to 3.14, so you just initialize first. Okay, so an initialized variable will invite okay, remark here, an initialized variables will invite garbage value, which is not meaningful. So what is garbage value? So I will show you an example here. I have a coding integer a, double x and b. So I forgot to initialize what is the value a and x and b, so I straight away run the program. See, it will produce me the result, but this is a wrong result. It's a garbage value. Okay. Okay, so here is another common data type that you will need to use is a string. So string is a sequence of a char or collection of series of a char. So you have two methods to write a string, either using C string or using a string count. Okay, so first method, C string. So it's an array of char. So if you have a single char, okay, so you just use declare using this char, then the variable name, and the single space will be created to store a single char. Okay, you can also use this char data type to declare a string by adding this bracket behind this variable name and state the maximum number of the char that you would like to store. Okay, so for instance, I have a char variable name and 20. You indicate this string contains of 19 chars in the length and plus 1 terminating null char. Okay, this is by default to inform the compiler to stop reading any char after this position. Okay, so important note here, we have two methods to read a word from a string. Cin to read a single word. It means that if there is a white space detected, it will just stop reading. If you would like to read more than one word including this white space, then you have to use this syntax: cin.getLength, your variable name, size of the string. You mentioned just now 20, then you have to put 20. Okay, so let's look at this example. Okay, char. Okay, so let's look at the example here. So I have name variables data type char and store 19 of a char, which is a string. So I run the program. So I put my full name. So it will just show me the first word. As I mentioned, if you use cin, so whenever you read the white space, it will just stop here. You will just stop here. We just show this first word. Okay, if you want to display all this go and then space here, then ching, then space and pound, then you have to use another syntax, which is cin getLine, cin dot getLine, your variable name and the size. So let's see what happens. Let's see out. My name here. So, okay, can you see the difference? If you want to read only single word, then you use cin. If you want to read more than a word including the white space, then you have to use cin.getLine. Okay. So move to the next method, string class. So same things. This is the method where you can store a string. So just a different method. Okay. So to use this string class, first thing first, you have to include this string header file, string library, and then using namespace standard. And second step, declare your variable using a string data type. Okay, then under your the value for this string must be within this double quote. If you leave out this double quote, it will give you the syntax error. Okay, so same as the C string, we have two methods to read the input. Okay, cin to read only single word. Okay, it will stop whenever there is a white space. Okay, or getLine cin variable name to read the whole string, including the white space. Okay, so let me show you the example here. Okay, I use cin now. I use cin. I put my full name. So you just leave the first word, then stop at the white space there. So you want to read this white space, then you have to use getLine cin your variable name. Okay, so it will read all the words, including the white space, in the string class. Its difference are getLine bracket cin variable name. So in the C string, it use cin.getLine variable name and size of the size of the array. Okay. When you are declaring the variables, one thing you need to take note is the scope. Scope is means how much extent the variables can be accessed. Bear in mind, a variable cannot be used before it is declared. So in this example, the declarations integer value equal to 100, okay, is after the use. Therefore, it will throw you the error. Okay, so you have to declare first. Declare your variable, and only you use the variables, else it will throw you the errors. So allocating memory. As I mentioned earlier, declaring a variable is actually use up a memory to store the value, and you can update the value during the runtime. In other way, we can also store a value or predefine a value before the program execution, but this value cannot be changed during the runtime. This value is fixed during the whole program execution. Okay, we call this value as constant. So the difference between these variables and the name constant is the value for this variable can be changed during the runtime, and meanwhile for this name constant, the value for this name name constant cannot be changed during the program execution. Okay, so here we have two methods to declare a constant. The first one declare, the second one define. So let's look at this first method first. So the first method, declare a constant, use the syntax const, abbreviation for the constant. And then what is the data type for the constant? The variable the constant name and the value that you are going to assign into this constant. Okay, and data value must be initialized during declaration and cannot be changed. It is for read only during the program execution. So here is an example on how to declare a constant. Okay, const data type, the name of this constant equal to the value. Okay, so it's what happened that you are trying to change the value for the constant. Okay, so let's try what happened if I try to change the value for the constant. So I declare a constant first. For example, constant integer value equal to 100. Okay, so I'm trying to disturb this value, constant value equal to value plus 1. Okay, see what happened now. So it will throw me this error because, as I mentioned, constant is the value for this constant cannot be changed. It is for read only. Now I'm trying to change the value for the constant, so it will throw me the error. Okay, so this is the second method to declare a constant. We call it as a defined constant. So how to define a constant? We have to use the directive of defined. Okay, what is the directive? We have to use this #. Okay, #, define. So syntax, #, define, name of the constant, and then the value. So as you notice here, we don't include the data type for this constant. Okay, #defined, defined, and then the variable name, the constant name, the value, just like this. So this is the first method to declare a constant. So I have a second method using this #, define value to no data type required, 200, and no semicolon at the end of the directive. So this is the second method to define your constant. Okay, clear? Okay, so program statement. So program statement is a statement that causes a compiler to carry out some actions. There are three common statements here: expression statements, compound statements, and control statement. So the expression statement consists of an expression that followed by a semicolon. For instance, you have a equal to b plus c, then followed by this semicolon, It's normally used to compute and write a value, or usually to call a procedure or functions, where I will explore to you more later. And we have a compound statement. It consists of a several individual statements enclosed with a pair of these places. It consists of a pair of these places. Okay, so these compound statements are normally used under the control statement, such as a for loop, if else statement. And the last statement here is the control statement, used to create a special program features such as the logical test, loops, and branches. Okay, so here while bracket count, this one is the control statement, and under this control statement we have a compound statement. Okay, so come to our last topic in this lesson, okay, which is a type conversions. So imagine that you have these expressions. Okay, you have one integer multiplied by this double. So look at this online compiler. We have a value of a equal to 15. We have a value of b formed by this double data type. So what will be the result if I multiply this a by this b, a is an integer data type, b is a double data type. Okay, what will be the result? So if I run it, the result will be in double data type. Okay, y. Okay. So as you can see here, the result is in the double data type. This means that there is some rules in the C++ calculations. So in C++, if the calculation of these expressions has more than one operators, okay, or more than one variables, the both variable must be in the same data type before the calculation can be take place. This means that before this multiplications come in, so somehow inside this, behind this C++, either one of the data type for these variables has temporarily converted to match with another data type for the another variables. Then only this calculation can be complete. Okay, so there are two types of a conversion in the C++. The first one is the implicit type of a conversion. Second one is the explicit type of conversion. So in implicit type of conversions, it means that C++ automatically convert one type to another according to the promotion order. Okay, so by default, C++ will help you to convert one data type to another according to this conversion length. So given these situations again, we have a equal to 1, b double 2.1. So what will be the result? Okay, so as I mentioned just now, C++ has a rule. In order to perform some calculations, we have to make sure both data types both variables are from the same data type. If both of them are from a different data type, don't worry, this C++ will help you to convert, okay, convert implicitly for you, where this int integer will temporarily convert into the double. For instance, 1.0. See, they are matched, same data type. Therefore, they can proceed to give you the answer 3.1. Okay, once the calculation is done, these conversions from the integer to double, this conversions is not valid anymore. Okay, and the data type for this a will convert it back to its original data type, which is integer. Okay, so remember the conversion is only for temporary, and the converted value will be back to its original data type as soon as the expression is finished. Okay, so you might ask, why in this expression the a from this integer must be convert into the double, not from the double to integer? Okay, why? So the answer is showing here, shown in the screen. It's according to the promotion order or conversion rank. Okay, so what is the conversion rank? Look at this figure. So this is the conversion rank. So the conversion is done based on the ranking in the figure shown on the screen. So go back to the example just now. We have an integer a, double b, right? So integer is in the rank number 4. Meanwhile, double b is in the rank number 8. This conversion will start from the lower rank to the higher rank. Therefore, this integer in the rank number 4 will be temporarily converted to the higher rank, which is double, to match the expression, to match the variable b, which is from the double data type. Okay, so we will promote this integer to the double. So this a will temporarily become from 1 to 1.0. Then match, yes. If match, then we can proceed, become 3.1. once the calculation is done, and then this conversion is no longer valid. So it will convert this a back to the integer. So here we have another example. What will be the result if I have a char plus a float? So char is in the rank number 2, float is number rank 7. So from the lower to higher, so this char has to be temporarily converted into the float data type, which are same ranking 7. Okay, meanwhile integer minus long, integer is in the rank number 4, long in the ranking number 5. So this integer will be temporarily converted into the rank number 5, and so on. So look at the last example, we have a short plus long divided by this float. So look at this, we have to solve the expression within the bracket first. Okay, so what is the ranking for short? Ranking number 3. Long? Ranking number 5. So this short will be promoted to the rank number 5. So temporarily we have a wrong data type here. So we have a long divided by float. Again, long is number 5, float is number 7. So the float will be promoted into a ranking number 7. Okay, so the answer will be in float data type. So we have an example here. Okay, C from the data type chart, which is A, and then we have another variable I from the integer 1, 2, 3, 4. So char is the ranking number 2 and the integer in the ranking number 4. So from the implicit type conversions, this C will be temporarily converted into the integer, right? So how to add A into 1, 2, 3, 4? Okay, so in fact every single char in the C++ is represented by the value. So you can find the value from this Ascii table. You can just go to the Google. Okay, you type Ascii Table. Okay, then you look at this Ascii Table, the official website. So you can see this is the Ascii Table, and each of this char here can be represented by the value. Okay, so we have a here. So what is the value for A? Look at this A. Yeah, so this is the A, and then go to this decimal DEC. So the value for A is 65. Okay, the value of A is 65, therefore 1, 2, 3, 4 plus 65, you will get 1299. Okay, so at this decimal, we are in decimal numbering system. Okay, so we have okay, try this. We have an exercise here. Char A integer I3650, short S78, and long double. And what will be the result when we have the I multiplied by S and D multiplied by C? Okay, comment your answer in the comment box below. Okay, so just now you have learned about this implicit type conversions, where the C++ will automatically convert the data type based on the promotion ranking. Okay, but this C++ is actually giving a chance to the user to decide their own final data type also. Okay, so you can do this by using this explicit type conversions. Okay, there are 3 methods to achieve that. The first one, specify your desired data type in front of the variable. Second one, use the keyword static underscore cast, and then put a symbol, the desired data type and your variable name. And finally, predefine the data type of a variable to desired data type first. Okay, we have our example here. So we have a number 1 and number 2 which are from the integer data type. Okay, so if let's say you would like to get your result in double, so you have to either change one of the data type into the double first. Okay, you just put bracket and put double. So it will convert this integer data type of this number 1 into the double. Okay, so since you have double divided by integer, so based on the implicit type conversion, the answer will be in double. Okay, else you can use second method, use the keyword static underscore cast and then double your desired data type, and then brackets your one of the variables here divided by integer. You have a double divided by integer. Finally, you will get the answer in double. Okay, so okay, we have a question here. This is the mistake that commonly made by the students. Okay, look at this questions. We have an integer number 1 9, number 2 integer also integer 2. Okay, if you divide this 9 to by this 2, you will get, supposedly you will get 4.5, right? But since both of these variables are from the integer, therefore your answer will be in integer also. Okay, same as this situation number 2. Okay, you have to put the bracket here, integer divided by this integer. Finally, you will get integer. But somehow you go and convert later. It is too late. Okay, it is too late. Okay, so you should put a bracket here. You convert the number 1 first. You convert the data type for number 1 first into double. Then only you divide by number 2. Then you will get the value in double form. Okay, same like this third situations. Okay, you have a number 1 in data type, you have a double. Supposedly your answer will be in double, right? But somehow the variable that you declare to store the result, you use integer as your data type. Therefore, you will convert the double into the integer data type. You will get 4 also instead of 4.5. Okay, so as a summary, you have learned some of the basic terms in the C++, such as identifier and how to declare variables, and how to convert the data types implicitly and explicitly. Okay, so I hope in this lesson you have learned something new about the C++, and also I will see you in the next lesson. Okay, bye.